Continuing with factoring by grouping. All right, we want to factor this quadratic equation into a binomial times a binomial. But because a is 2 and not 1, you could either try your box method, and box is just factor by grouping. So we're going to continue factor by grouping. All right, in order for us to do this approach, we're going to multiply a times c. A is 2 and c is -3. So we're multiplying 2 times -3 and getting -6. And then what we want is we want two factors of -6 to add to b, or the coefficient on the linear term. So what multiplies and gives us -6 that adds to 5? All right, let's begin by listing all the factors of 6. Let's ignore the negative for just a moment. So 1 and 6 and 2 and 3. Our objective is to find two numbers that multiply to -6 and add to +5. So in order for us to get a -6, we're going to have to make one of the two of the pairs of factors a negative. And let's just take a look at 2 and 3 as factors. If you made the 2 negative and added to the 3, you wouldn't get 5. Or even if you made the 3 the negative, so that when you multiply and get -6, 2 plus -3 wouldn't add to 5. So it has to be that it comes from the pair 1 and 6. So let's make 1 negative, because when we add -1 and 6, we're going to get 5. So our approach to factor by grouping is to split up the linear term 5x into the sum of two other terms comprised of these coefficients on those terms. So keep the 2x squared. And instead of writing 5x, we're going to write -1x plus 6x. -1x plus 6x. If you ever have a positive and a negative, it might be best to put the negative, the minus term first. All right, now go back into the problem. We just want to keep the -3, keep the equal 0. So you can check your work by collecting these two terms and seeing that you get back to what we started with. Okay, we're going to factor by grouping, so the next step is just rewrite the problem. Okay, now what we want to do is we want to put the first two terms in its own parentheses. And right here, notice that I'm going to put a parenthesis here. Well, that plus, and that plus 6x, okay, that by my putting that parenthesis there, I didn't change from a positive 6x term. Just keep that in mind for later, and then close the parentheses here. Okay, so factoring by grouping, we're going to factor the common factor out of each of these binomials. So common factor here to take out is x. When I divide out an x from 2x squared, I'm left with 2x, and from x, I'm left with -1. Okay, write down the plus sign. I'm not ready to go to the two parentheses yet. Take out a 3, and I'm left with quantity 2x minus 1. If you're not sure about your factoring, you need to check right here and distribute your x back in to see if you get back to what you started with. And if you're not sure about your factoring here, you can always check it. Distribute the 3 back in, see if you get back to what you started with up here. Okay, we're going to factor, so we're going to factor twice. Okay, so the next thing in this step is to look at these two terms right here and see what they have in common. Well, if we did all our work correctly, they should have a common parenthesis, a common binomial. So if I factored out 2x minus 1 here, that would leave me with an x. And if I factor out 2x minus 1 here, that would leave me with a plus 3. So I know this is a lot of work right here. If some of you guys are comfortable in going from here to the final answer just by guess and check, that's fine. Otherwise, we have a strategy to go from here to here. All right, continuing to solve, set each factor equal to 0 and solve. I'm going to do two things in one. I'm going to add 1 and divide by 2. Okay, we always want to go back and put each of these in for x one at a time and see if they check, and save time. I'm just going to tell you that they do. So let's continue with another example. Okay, so for example number 7, we're going to factor. Okay, well, in order for us to factor, I notice that a is not 1. I might go over here and do the factor by grouping technique. So what multiplies to -6, multiply a times c, but adds to the coefficient on the linear term, and that coefficient is -1. So multiply a times c, and then add to b. All right, factors of 6 are 1 and 6 and 2 and 3. And like in the previous example, okay, if we need a sum of -1, we're probably going to be working with the pair of factors 2 and 3. Let's make 3 negative. So 2 plus -3 does give us -1. So we're going to take and break apart minus 1x into 2x minus 3x, which results in the same minus x. So keep the first term, 3x squared. Break up minus 1x. I'm going to put the minus term first, so minus 3x plus 2x. And then bring down the minus 2 that was in the original problem. So you're keeping the first term, the leading term, the constant, but you're breaking up the linear term. So I get 4 terms, so I can group. All right. So let's rewrite the problem, and then we'll apply parentheses. Okay, no harm there, putting those two together. No harm here after an addition sign by putting those two together. Okay, now we're going to factor twice. Common factor here, common factor here. 3x will pull out of both these terms, leaving quantity x minus 1. Bring down the plus sign. 2 will factor out of that binomial, leaving x minus 1. As you're writing this down, you should notice that it's the same as the first binomial, and if it's not, you probably just made a sign mistake. Go back and look for it. Okay, next step, let's factor again. So what do these two terms have in common? Well, that parentheses. So let's factor out that parentheses, and that leaves us 3x. We don't need the plus sign anymore. We're factoring out. We always start with the parentheses then. So we've got 3x here. And when you take out x minus 1 here, you have the plus 2. If I was just factoring, I'd be done, but I'm solving. So in that case, set each factor equal to 0. I'm going to subtract a 2 and divide by 3. As a last step, you want to check these proposed solutions as x is back in the original problem to see if you get 0, and to save time, I've done that. Okay, we're going to do one more example of factor by grouping. I just decided to manage my number 8, put it up here. You can just continue underneath 7, whatever you want to do. Okay, let me include the equals 0, otherwise we're not solving, we're just factoring. Okay, it'd be kind of difficult to go right into the answer, the binomial times the binomial. So since I see a is 8, I'm going to do factor by grouping, the AC method. Okay, so what multiplies to 32, a times c, but adds to -33? Ooh. Let's list the factors of 32. I start with 1 and proceed forward. So 1 goes in 32 times, 2 goes in 16 times, 3 is not a factor of 32. I go to 4. 4 times 8 is 32. 5 is not a factor, 6 is not, 7 is not, 8 is, but I start to repeat myself, so I'm done here. So which of these pairs of factors, when both made negative, add to -33? Well, it looks like the -1 and the -32, okay, would have to be the pair I'm going to choose to add to -33. All right, so we come back into the problem. Keep 8x squared. We're also going to keep the 4, but we're going to break minus 33x into these two, into two linear terms having these coefficients. And in this case, they're both negative factors, so we don't have a choice. and putting just one negative factor first and making the second one positive. So minus x minus 32x, because that again will collect to the minus 33x. Bring down the plus 4, bring down the equal 0. Okay, let's write the problem down again and then do some factoring. Okay, I'm going to group these two, and that's okay. Nothing changes, no harm there. Okay, but notice that when you put the parenthesis right here, you just made this minus 32x term a positive 32x term by separating the subtraction sign. Well, if I'm changing the sign on 32x, then I've got to change the sign of the 4, everything that follows. So in that case, if this is minus in front of your second term, and you put that parenthesis on the second set of terms, then you need to come in here and adjust that to a minus, and then close your parentheses. Think about why you have to do that. When you distribute this negative to check your work through, you've got to get back to the previous line. If I distribute this negative through, I will get back to negative 32x, and when I distribute the negative to a negative 4, I will get back to the positive 4. Another built-in check process is both of these parentheses in this first step have to have the same operation. If this is minus, this needs to be minus. Okay. I'm going to continue by pulling out a common factor from each set here. So x comes out, leaving 8x minus 1. I'm bringing the subtraction sign down, pull out a 4, leaving 8x minus 1. Both binomials are the same, so I'm going to go ahead and proceed. And I'll take out the common factor from these two terms. 8x is the common parenthesis, and in the other parenthesis I will have the remaining factors of x minus 4, set equal to 0. Continue solving by setting each factor equal to 0. Add 1, divide by 8. Add a 4. Both proposed solutions should be checked individually in the original problem, and I've already done that. Those are both good solutions. Okay, at this point we're going to go on to the second of 4 ways that we can solve a quadratic equation. So we did factoring, now we're going to do the technique of extracting square roots. All right, let's solve for x. Okay, unlike the previous examples, notice that we don't have a linear term. We don't have an x term. We just have the square term and a constant. So instead of solving for 0, putting it in general form and trying to factor, there's another technique if you notice you don't have a linear term. Okay, and that other technique is to isolate the x square term, get it by itself, and then bring in the square root symbol. So that's what we'll do. So let's isolate the x squared term, divide both sides by 4. So we're going to end up with x squared equals 3. Okay, at this point we can bring in the radical, the square root, because I have a square power, I have 2 power. Okay, I'm going to go ahead and write the problem down again. X squared equals 3. And then I'm going to bring in the even root, the square root, because 2 is even, and I'll bring it in on both sides. Okay, anytime we have a situation where we have an even power, like 2, 4, 6, 8, etc. Not odd, like 3, 5, 7. Anytime you have an even power and you bring in the appropriate root, like the square root. Okay, what we're going to do is we're going to bring out an x, but we're going to bring it out as the absolute value of x. So let's get in the habit of doing that. Not for odd exponents and appropriate roots, but for even. For example, if this was x to the 4th and I brought in the 4th root, I would bring the x out with the absolute value. If it's an odd root, x cubed with the cube root, I just bring down x. Okay, you'll see why in a minute. Okay, and square root of 3 can't be simplified, so I'll just write that down again. Okay, next up I'm going to remove the absolute value, and anytime you have an even root, you're going to have 2 solutions. So at this point, when you remove the absolute value, you make the adjustment and you put both positive and negative in front. Okay, so our 2 solutions are negative radical 3 and positive radical 3. And again, you want to check these back in the original problem. They do check. They're both good solutions. They're irrational. They're real. There's no imaginary. Okay, but they're irrational. So let's do 4 total examples of extracting square roots. I guess I'll put 2 right here. Okay, our objective is to solve what values of x will make this work. An option is you could FOIL, subtract 7, 0 out one side, and try and factor. But then I think the factoring is not going to work and you're going to have to use quadratic formula. So even though I might have a linear term here, we can take advantage of the technique of extracting square roots by bringing in the radical. So isolate the square. It is isolated even though it's a binomial. So let's write the problem down again. Let's show that we're bringing in the radical. And in this lesson, because we're dealing with quadratics, the second degree, we're always going to have to bring in the absolute value. All right, so let's bring out x minus 3, but put it in absolute value. Just bring down the square root of 7. Okay, now when you remove, the next step is to remove the absolute value. You can't add 3 yet. The next thing in the order of operations is to remove the absolute value, but every time you remove an absolute value, on the answer, let's make the adjustment of plus minus. And we put that up front. Okay, now to isolate x, we're going to add 3 to both sides of the equation. So if I add 3 here, I'm going to isolate x, and I'll have x equals. So where do you put the plus 3? Well, common practice has us put it in front of the plus minus. I wouldn't want to tack it on back here. I could, it wouldn't be wrong. Common practice, though, has us add the 3, put the 3 in front of the plus minus, radical 7. So one solution is x equals 3 minus radical 7, and the other one is 3 plus radical 7. And just take a look at those numbers right there anyway. You wouldn't be able to get those by factoring. You would have to use quadratic formula if you decided to FOIL, solve for 0. You wouldn't be able to factor. You'd have to use quadratic formula to get solutions, real solutions of this type. Okay, 2 more. All right, we're going to continue extracting square roots with these last 2 examples here. Again, you could FOIL, add the 9, 0 one side out. Try and factor. If that didn't work, quadratic formula. Okay, I know we haven't discussed that yet, I don't think, so we're not going to go that route. And likewise over here with number 4. All right, but to use the technique of extracting square roots, so write the problem down again and bring in the square root. Okay, notice we're going to have an imaginary solution. If they ask us to find all real solutions, we would be done because this would not produce a real number. It would produce an imaginary number. But if they say find all solutions, real and imaginary, we'd want to continue. And that's what we're going to do. We're just going to continue and find all solutions. So we have an even power, even root. So we bring out 2x minus 1, but we put it between absolute value bars. Okay, cleaning this up, this is 3i. Next step down, remove the absolute value. That's what we do next. We have to unleash the 2x minus 1. So we're going to have both positive and negative 3i. Okay, so now we're going to add a 1 to both sides. So common practice, again, would have us add the 1, put the 1 in front of the 3i. As the last step, we're going to divide by 2. So we'll just stack this fraction here. So both our solutions are imaginary. The 1 minus 3i over 2 and 1 plus 3i over 2. They're imaginary. So again, just pay attention to the directions. Are they asking you to find the real zeros? Because if the answer was yes to find the real zeros, then we'd have no solution. That's what you would report because we don't, we couldn't accept the imaginary solutions. Okay, let's look at 4. Again, you could FOIL, solve for 0, try and factor. It's not going to factor. We'd have to use quadratic formula, but we're not doing that because we haven't covered that yet. We're just going to extract the square roots. Notice again, if they said find real solutions, we'd be done. You just say no solution because there'd be no real solutions. There's only going to be imaginary solutions as indicated by that negative underneath the radical. Okay, even power, not odd, so bring out 3x minus 2, put it between absolute value bars. Pull out the I radical 6. I can't simplify square root of 6 like I did the 9 over here, so we're going to have this type of term here. All right, remove the absolute value next. When you do, make this plus minus I radical 6. Let's continue solving for x. Let's add 2. It'll go up front. Let's divide both sides by 3. So we have two solutions, 2 minus I radical 6 over 3 and 2 plus I radical 6 over 3. I'm not going to write them separately. Just hope you see that there are two solutions, two imaginary solutions. So again, pay attention to the directions. Are they asking to find all real solutions? Because if so, we would have been done way up here and we would have said no real solutions. Okay, that concludes 2 of the 4 techniques for solving a quadratic equation.